Hello, class. For today, what we're going to be going over are our 4.0 notes, which is going to be our exponent rules. So this is a graphic organizer, and we're just going to go through these problems and talk through all the different rules. And hopefully this gives you a refresher of when you did this in Algebra 1. So for the first one, we are going to be looking at adding and subtracting monomials. Remember, monomial means that there's just one terms. Now, the big thing for this one, again, is you've been doing this one for quite a while now. We are going to be combining like terms. So again, when we combine like terms, that's just you adding and subtracting the monomials. Remember, when you combine like terms, just remind yourself you do not change the variables and exponents. Do not change. Don't overthink it. You just keep it the same. So over here, let's look at problem number 1. On this one, 9x squared y minus 10x squared y. Again, I just want to double check. In this case, I look, are the variables exactly the same? In this case, yes. So then all we're going to do is 9 minus 10, which is going to give us negative 1. Again, we just focus on the coefficients. Again, the numbers out in front. 9 minus 1, or 10, we get negative 1. And again, like we said, all you're going to do is keep this variables the exact same. Do not change. Just like that. Number 2, this one is a word problem. This one's just a little bit tricky. On this one, it says subtract 6w. So when it says the word subtract, whatever is following it, that's going to be second. We're going to subtract that. So in this case, we're going to do 8w minus 6w. I want to make sure that it's the 6 that I'm subtracting. Again, a lot of people mess this up because they accidentally go in order. They do 6 minus 8. Subtraction, you do need to be careful. So again, 8 minus 6, I get 2w. That's going to be your answer for this one. And I'm just going to move that over here. All right, so that is that first section, adding and subtracting. Now let's look over the product rule. So product rule is whenever we're going to be dealing with multiplication. So what I want to do is let's look at number 1 first, and I'm going to go about it the long way. So we're looking at this first one. Remember, squared and exponent of 2 tells you that we're multiplying it 2 times, so we got h times h. Here I'm going to rewrite this one. That's going to be 6 h's, so times h times h times h times h times h times h. Now, obviously, we do not want to do this every single time. Again, notice we're multiplying all these guys, so we can essentially combine these, and we're going to have a total of 8 h's. Now, obviously, we do not want to do this every single time, so instead of doing that, notice 2 and 6, what I could do is just add those two numbers, and I could get 8. And that is the product rule. So again, that's a long way to go about it. All you're doing is adding our exponents. So in this case, it'd be x a plus b. All right, so let's look at number 2. Now, when you have coefficients, that negative 2 and that 7, you're going to treat those guys like normal. We're going to multiply them. So in this part, we'll do the coefficients in red. Negative 2 times 7, I'm going to multiply them, and I get negative 14. Now I'm going to look at my a's right here. A squared, a cubed. Again, I see they're both a's. I see there's 2 on the left. There's 3 on the right. We add those two exponents. I should get a to the 5th. All right, and then same thing. We look at b. Again, remember, if there's no number there, again, in math, sometimes mathematicians don't write everything out. In this case, it's an invisible 1. Again, if there's no number there, it's just a 1. We didn't write it in there, but that would be b to the 1st plus b to the 1st. We get a total of 2. And that is your answer for this one. All right, let's look at the next one, power rule. So just like the last one, let's look at number 1. We'll go about it the long way, and then we'll see how the shortcut happens. So on the power rule, again, when I do this the long way, we start out with this 3. That cube tells me I have 3 sets of x squared. So that's the first thing. And now I'm going to rewrite it again because each x squared tells me there's actually 2 x's in each one of those. So again, there's all those guys. And notice, now I'm going to count out how many x's I have, and I should end up with a total of 6. So again, I'm not going to want to expand them every single time. Instead, this time, what you're going to kind of do is you're going to kind of distribute and multiply. So in this, we're going to do 2 times 3, and that's where we get that x to the 6. So again, that would be the shortcut. Instead of expanding it and going about it this way, we are just going to multiply. So again, what we're going to do is we're going to do x is equal to a, the power of a times b. We will multiply those. All right, let's look at problem number 2. So we're going to ignore this guy first. Again, we're going to focus on the exponent on the outside. So again, when we are dealing with the power rule, I always tell my students, look for an exponent on the outside of the parentheses by itself. So again, in number 1, it was a 3. In this one, it is a 2. Now, we will multiply it. The big thing is, remember, you need to multiply to everything on the inside. And this negative 2, it has an exponent of 1, just like these b's over here. Again, there's nothing there except that invisible 1. Same with this negative 2. All right. In this case, I'd get negative 2 squared and m to the 5th. And then we'll copy down this times m cubed. Now, one thing I always like to tell my kids is negatives and exponents do not get along. Make sure if you have a negative 2 or a negative number, you put it in parentheses. That way, your calculator, again, this is mostly for the calculator. This is so your calculator recognizes the negative goes with the 2, or else it's going to think it's just a 2, and then it's going to save the negative for the outside. All right, from here, what we're going to do next is we are going to simplify. Again, we can type this into our calculator. We cannot type the m's in there, but I can put negative 2 raised to the power of 2, and I should get 4, and I'm just going to copy down the rest, m to the 5th times m to the 3rd. All right, from there, all we're going to do is multiply, and I'm going to get equals 4m to the 8th. Again, here all we did was the product rule. I had 5 on the left, 3 on the right. Add them up and we get m to the 8th. And again, it's just a 4 there because there's nothing there, or you could have done 4 times 1. All right. Now, the next rule should come fairly easy. Product rule and quotient rules are pretty similar. So again, on this one, when we have the product rule, actually the quotient rule, I'm assuming you'll be able to guess. Again, look up here. When it was a multiply problem, we added our exponents. When we do the quotient rule, we're going to subtract our exponents. We're going to do a minus b. All right, and really quickly, I'm just going to show you how come. Whoops. The reason is if I have x, let's just go with x to the 5th over x squared. Again, you don't have to write this down. Just explain it real fast. Again, I have 5 x's on top, 2 x's on the bottom. From there, I'm going to cancel out these pairs, and I should be left with just x cubed. Only 3 x's left over. So again, that's why that is that. Again, they'll cancel, and that's why we subtract. All right, number 1, on this one, just like the product rule. So if we look at number 2 right here, remember we treated that negative 2 and that 7 like normal, and we got that negative 14. We multiplied our coefficients. On this one, we are going to divide 27 by 42. Again, we do not want decimals, so in this case, you're going to have to simplify it. Again, if you have a calculator, again, if you have a calculator, that would be a great time to use it. Let's see. So I'm going to divide 27 divided by 42. For both of these guys, again, I'll get a decimal, and if you can use the fraction button, I would recommend it. Or if you want to go old school, we try to see what goes into both of them. Okay, in this case, let's see, 3. And I should be left with 9, over 14. Okay, we get 9/14, and then all we're going to do then is just subtract this. So x to the 5th over x to the 1st. I'm going to subtract 5 minus 1, and I'm going to get x to the 4th. So again, simplify and divide the coefficients. That's 27 divided by 42 reduces down to be 9/14, and then 5 minus 1 for the variable, and you get 4. All right, on the bottom, on this one, first thing I see is I want to take care of that. So remember, we are going to multiply this, and then we should get y to the 4th over y to the 4th. After that, 4 minus 4, that's going to give me y to the 0, and that is going to lead us to that next rule. So when you get y to the 0, a lot of people think it is a 0 for our answer. This is not true. Okay, when you get 0, it is going to equal 1. So try to come up with a way to remember that. Y to the 0 equals 1. So since we're already on that, let's just finish up this one. We'll skip ahead. 0 exponent rule. Again, we just said it. This is always going to equal 1. All right, so the moment I see this x to the 0, again, I'm just going to copy down that 7, and I'm going to replace x to the 0 with a 1, and then from there, I'm just going to solve it. So 7 times 1, I just multiply, and I get 7. All right, down below, this one's going to be pretty similar to the one that we did in the other set. Again, first thing I'm going to do is distribute this 2. I get w to the 8th. Again, we multiplied because that is the power rule. And then from there, w to the 8, I just copy down that w to the 8th again. I subtract, and I should get w to the 0, which again, that just equals 1. All right, very last one. For this one, negative exponent rule. You can never leave your answers with a negative exponent. Just remember, a negative exponent on this one, that just means to flip it. So if I have this x to the negative 8th, what's going to happen is I'm going to flip this to the bottom. Again, remember, especially from slope, if we ever needed this to be a fraction, we just put it over 1. In this case, it's in the numerator. This is now going to flip to the denominator. And I'm going to get x to the positive 8th. Okay. After that, again, I can't leave it blank on top. And very similar, we're just going to put a 1 on top. And this is what you should get. Okay, this one will make a little bit more sense once we do an example. So, looking at problem number 1. On this one, I always like to start out with my little fraction bar. On this, I look to see, do I have a negative exponent? The answer is yes. That means that this x to the negative 2nd, that's got to flip to the bottom. So I'm going to put it in the denominator. In this case, I look to see there is no negative exponent here with the negative 5. So what I'm going to do is I'm just going to leave it on top as negative 5. Remember, it's not negative numbers, it's negative exponents that are going to be affected. All right, so that's going to be your answer for this one. All right, next one, we got division. So remember, we will treat the big numbers, the coefficients, the numbers out in front, we'll treat those like normal. So 4 divided by 8 is 0.5. And if I hit the fraction button, it'll be 1/2. Or again, you could just do 4/8. Again, in this case, I would divide by 4 to simplify this, and I should get 1/2. All right, from there, I'm going to look at my k's. I will look at their exponents. 2 minus 5, I'm going to get k to the negative 3rd. Now, I cannot leave it like this because that is improper having a negative. So what I must do is I need to flip it to the bottom. So in this case, k to the positive 3rd, and then I'm going to get 1 and a 2. Okay, and that is your answer for that one. All right, so again, this is your properties for exponents.